Good morning.
Good morning, sir. Good morning, all. Very good morning to all the students, faculty members, and today's chief, Dr. S. Vijayan. So, Dr. Muttamil Children, sir.
Yes, sir.
Shall we start the program?
Yes, sir. Yes, sir. We can start. Guest is already there in
Right.
me.
Right.
We can start now.
Yeah. Sir, start பண்ணலாங்களா sir, Doctor?
Okay.
Sir.
Yes.
Yes, sir. Thank you. And once again, very good morning to all of you. Respected our beloved professor and geospatial chair professor, Dr. S.M. Ramasamy, sir. Respected then HOD and UGC Emeritus Professor, Technical Advisor of Digital Pumbuhar Project, Dr. C.J. Kumanan, sir. And my dear fellow colleagues, Dr. A. Balakarasu, Dr. D. Ramesh, Dr. C. Lakshmanan, Dr. J. Sarabhai, and Dr. A. Muttamil Chelvan, Dr. R. Saktivel, Dr. R. Jagan Kumar, Dr. Masila Mani, and all the guest lecturers of our departments, and other professors, dear professors from all other departments of our own university, and project staff, research scholars, office administrative staff, and media friends, and my dear friends, student friends. A very pleasant good morning to all of you. And this is a half-a-day seminar on planetary remote sensing. This is being conducted in commemorating the 102nd birth anniversary of Dr. Vikram Sarabhai, the first chairman of ISRO, and who is the father of Indian space program. And many more awards have been conferred to Dr. Vikram Sarabhai. He's Dr. Vikram Sarabhai did his PhD under the guidance of Sir C.V. Raman, and he was born on 12th August 1919. He was an Indian physicist as well as astronomer, and he has initiated all the space research and helped to develop nuclear power projects in India. And if I remember correctly, I could also quote this. Actually, I will just tell the information that Dr. APJ Abdul Kalam, the ex-president of India, worked under the leadership of Dr. Vikram Sarabhai. He has mentioned that Dr. Vikram Sarabhai is his own role model, is a mentor and a great leader and everything. That is what he has mentioned in his autobiography. So, Dr. Vikram Sarabhai was honored with the Padma Bhushan during 1966 and Padma Vibhushan posthumously in 1972. So, we are very happy to honor him by conducting a seminar today in our department on behalf of the department and Bharathidasan University. I am very happy to welcome all of you to this half-a-day seminar, and with the support of the faculty members of DRS, Department of Remote Sensing, I feel very happy. We feel very happy in organizing this seminar. And first of all, let me welcome the chief guest of this half-a-day seminar. It is a great honor to me to welcome Dr. S. Vijayan. He has been awarded PhD during 2013 in remote sensing, awarded by the famous university in Tamil Nadu, Anna University, Chennai, and he has developed lots of expertise in the field of planetary remote sensing for about more than 9 years in the fields of Mars, Moon, Earth, IC satellites exploration. Okay, from Planetary Science Division. He is working even now in Planetary Science Division, Physical Research Laboratory, Department of Space, Government of India, Ahmedabad. And Dr. Vijayan has published more than 50 research articles in leading national and international journals and conferences during this short span of not more than a decade, or around 9 years only. Within this short period, Dr. Vijayan has published so many articles. He has conducted a lot of research works. To his credits, Dr. Vijayan has also been conferred with several awards, like Young Scientist Award during 2018 by Indian National Science Academy, and Career Development Award 2010 by Lunar and Planetary Institute LPI USA, and a Senior Research Fellowship during between 2010 and 2012. He was awarded by CSIR, Council for Scientific and Industrial Research, and he is also guiding doctoral research scholars in the fields of planetary remote sensing. And he has also visited our department during September 2019 in accordance with the IMSA Visiting Scientist Program. And he has delivered an excellent lecture during that day. And we found him as a very great human being with the best humanity. So I thought it would be very apt to invite Dr. S. Vijayan sir to deliver his lecture. So we are all thankful to you, sir, for readily accepting our invitation within a short period of 2 days. Just 2 days back only, we contacted him. Sir has very generously accepted our invitation, and very happy. He is very happy to be with us today, and we are also too happy with you, sir, with us
Thank
today.
you.
Thank you. And I will also interested in introducing and welcoming our founder professor, because 30 plus new students and other students have also joined with us. So let me introduce our founder professor. It is most important one now, I thought. So he is none other than Professor Dr. S.M. Ramasamy, who has excellent service record of more than 45 years, I think around 50 years now, in various capacities in Geological Survey of India, in Anna University, in Bharathidasan University, in Gandhigram Rural Institute, and in Deemed University, and Allahabad University. So in Bharathidasan University, initially as a first HOD of School of Earth Sciences, Sir has founded the Center for Remote Sensing. And he was the director of the center, first HOD of the center, and in various capacities. He was also involved in various capacities like Dean, Syndicate Member, former Vice Chancellor of Gandhigram University, and so many other famous designations have come to Sir. And Sir has Sir was in different capacities. Apart from that, Sir has invited several giants to our own department, like Dr. APJ Abdul Kalam and all. So in that way, we are very happy to welcome you, sir, to this seminar. And let me take this opportunity to welcome our then ex-HOD and Professor C.J. Kumanan, ex-HOD and previous second founder, professor of the department. And is also, we call our sir as a brother, Professor Ramasamy sir. We call him as a father of our remote sensing, father of our department of remote sensing. And our Professor Kumanan sir is lovingly called by all of us as a brother, professor of remote sensing. And sir has got more than 15 years of excellent services in our department, and sir has more than 15 years of experience in GSI also. And in various capacities, sir was working in our department, and even now, sir is very active. Even after his retirement, sir has hold an excellent position, very precious position like emeritus professor from UGC and personal advisor to VC, and now as a technical advisor to the national mission project known as Digital Pumbgar. We wholeheartedly welcome you, sir, to this seminar. And I welcome all the dignitaries and my own faculty colleagues and all the faculty, colleagues, and professors of our university, and all the administrative staff, project staff, research scholars, students, and media persons. And this morning, I could see some of the dailies have quoted this event and today's event, especially the number. I have seen that they have given advertisement about this particular event. So I thank the media also, including the number at this time. So with this welcome note, a very hearty and pleasant welcome to all of you, each and everyone, to all, and thank you so much. And now let me invite Dr. Vijayan sir to take the session. Thank you, sir.
Yes, thank you. I'll be sharing the screen.
Meantime, excuse me, sir.
Yeah.
And I also welcome the another excellent high expertise is also joined one Dr. Sambandam from GSI, retired director from GSI. Dr. Sambandam sir, we welcome you wholeheartedly.
So my screen is visible?
Yes, sir, it is visible.
Okay.
And you are also audible.
Yeah. So I thank first Palanivel, Dr. Palanivel, Dr. Sarabhai, and the Ramasamy sir and others who are there. And I welcome all students for this lecture. I'll be talking about the planetary remote sensing and overview. If any students have any doubts in between, they can stop anywhere and they can ask me. And even if they want to ask in Tamil, that is also fine. They can ask. I can reply back in the same. Don't hesitate. Ask whatever or wherever you want to it. So, as the title says, we will be looking into the planetary bodies through our remote sensing techniques. So I will give an overview about some of the planetary bodies. In this image, I have put the left side one as the moon, and the right side one is the Mars. So these are the two major satellite and planetary body which I'm working on. But in this talk, I'll be giving about an overview about the inner solar system bodies, how to observe these planetary bodies, what are the features present, what are the geological activities that has happened, and how to interpret them and what we can understand from these planetary bodies. To start with, we have to go back to just 4,600 billion years ago, when all the planets were closer to sun and it is as a dust. And after some time, the planets started forming. When you look at the initial stage, the planets were all closer to sun within 1 astronomical units, and they are very close by. And these red and blue dots are the leftover materials during the accretion. Then slowly, the planets started to gain this motion, like they started to settle at their current position, like this is the Earth and all. But still, when this settlement starts, the leftover material started moving. And where in the current stage, this is how our planets are settled. Interestingly, our planets has been migrated from closer to the sun and currently it's settled at a very far distance. During this settlement, there may be lots of events that was resurfaced or modified during each of the planetary bodies, whether all these records are preserved. But on Earth, many of the records are not preserved. That is the reason we go for the planetary science, because in these planetary bodies, the older records are still preserved because they have not modified that much. So that gives an idea. By studying the other planetary or satellite bodies, we ourselves able to understand what happened on the earlier phase of Earth. So that is the reason we started from Earth remote sensing to planetary remote sensing. And it is a mutual way we will understand both the bodies or many of the bodies in the solar system. If we separate the planetary bodies into two subdivisions, one is the terrestrial and the Jovians. The terrestrials are rocky ones, and these Jovians are gas giants. The Mercury, Venus, Earth, Mars in association Moon, they all fall in the terrestrial things. And the Jovians are Jupiter, Saturn, Uranus, and Neptune. So in this talk, I'll be focusing only on the terrestrial planet and how the remote sensing helped them to understand. And I'll be more specific on Mars and Moon. How to understand these terrestrial planets? It is very simple. They are close to Sun. They have different masses and radius. Mostly they are rocky and have solid surface. The density has a variation with respect to each planetary bodies, and their magnetic fields vary, and they have few moons, each of them. Like Earth has one, Mars has two, kind of thing. So this gives a very short brief about this one, but I'll go into detail about this. But to study about all these planetary bodies, what are the missions that has gone? That is very much important. Otherwise, if there is no any satellite orbiting these planetary or satellite bodies, we can't able to understand them. Starting with Mercury, Mercury has one mission called Messenger, whereas Venus has more than 3 missions. The latest one is Atasaki. And of course, the Moon. The Moon has all sorts of missions, like from lander, rover, human mission, satellites, all sort of things are there on Moon, which is as similar to that of Earth. We have in-field remote sensing, we have aerial, we have then satellite-based remote sensing. So next to Earth, the Moon has very diverse information in terms of in situ and in terms of remote sensing satellites. Next to Earth is the Mars. The Mars is just one step behind Moon in terms of the observations. They don't have any human mission still now, but it has a lander, rover, multiple orbiters orbiting them. Even our own Mongolian is orbiting still on Mars. So this gives, actually, if you take the remote sensing part, if you have more number of planetary missions, then you are having very good amount of data and very good resource of images to study these planetary bodies. That's why we have the neighbors of Earth, the Moon and Mars, where we have plenty of missions, and that made one of the research area to start with how this planetary and the satellite body are evolved through the geological timescale. In a nutshell, the Jovians, yeah, they do have missions, but now you see the number of missions which are encircling these planetary bodies. Jupiter is a couple, and Saturn as a Cassini. This mission has ended, whereas there are other missions to beyond Pluto and above, like New Horizon. That is one mission. It is not a mission which will orbit the satellite. Usually in remote sensing, we will go around the planet in an elliptical or in a polar orbit, so that we will keep on continuously monitoring the entire planetary surface. But the New Horizon mission, which has just surpassed Pluto, it's a flyby mission. That means it was going from Earth. It crossed all these planetary bodies. While passing Pluto, it just imaged Pluto. But it has imaged extensively, and it has just gone towards the Kuiper Belt asteroids. So that means we have very limited amount of images or data regarding Pluto. But for Cassini, the mission is dedicated towards Saturn. We have so much plenty of information about the Cassini and even the rings, which is a special specially located for the planet Saturn. As I said earlier, the talk will be more focused on the inner solar system. Inner means I define the one which is within Mars, like Mercury, Venus, Earth, Moon, and Mars. So I'll be not talking about Earth in this talk. I'll give a glimpse about these two bodies in a short, and I'll give these two in a very brief. How diverse remote sensing images we have, and how much science has been derived from these two bodies. To look into the major geological or the surface process which are present in these planetary bodies, one is the volcanic process. They are present in almost all the planetary bodies. The impact craters. The impacts are the dominant. You have millions of craters in in at least these two planetary bodies and here. And weathering means it in terms of with atmosphere, without atmosphere, like space weathering. All the process of weathering is acting in all these process planetary bodies. And glaciers, and if you look over the glaciers, it is only fit for Mars and Earth. Again, the fluvial, mostly it fit for the Earth and Mars. That means now all these 5 processes there on Earth, the sum of this process occurs in a combination in either of this planet, or all this is present in Mars. So that means the Mars has all of the process which Earth is currently having, but once Mars had in its past. The Moon has few, except this glacier fluvial. Other things are there on Moon. Again, the same thing. The first 3 is present on these 2 planetary bodies. Now, what is present? Laporte et al. Has given a geological timescale history for the Venus, Earth, Moon, and Mercury. First, we'll start with Venus. If you look at Venus, this MF represents the magnetic field, VA represents the volcanic activity, and the SLW represents the surface liquid water. If you look at Venus, it is a very surprising planetary body where there is question mark for the last 4 billion years. You don't have any information about the last 4 billion years. You have information about the last 1 billion years. What is the reason? And if you look at, we have no information about all these things. We have only information about the volcanic process. That too in the last 1 million years. That means the entire Venus surface has been highly modified by this volcanic process. Whereas, if you look at Earth, yeah, we have magnetic, we have volcanic, we have plate tectonics, we have liquid water on the surface. Yeah, Earth has all the things. But still, in compared to Venus has only volcanic resurfacing. That's what this planet is really hot. Now you can see the temperature, it is 740 Kelvin, and the pressure is 92 bar, which both are in very extreme state. Whereas if you look at the Earth temperature, the average comes around 300, and the pressure is just 1 bar. You can see a huge difference in the pressure difference. And coming to Moon, so on Moon, the major things known as the magnetic and the volcanic activities. You see, the volcanic history of the old 4 billion year things are still preserved on Moon. But look at Earth. We don't have any information of the oldest volcanic activity on Earth. We don't have, but we do have on Moon. It's still preserved. This way, if we land, or if we go to this part of the Moon where there was a lava was older than 4 billion years, that will give about the pristine information about the satellite Moon. But that information is not currently available in our own Earth. In that way, this is mutual understanding. If you understand about the earlier volcanic history of Moon, you may understand the history of Earth. And coming to Mars, we have very little magnetic field in the old. We have a large volcanic activity. Yeah, plate tectonics is still a mystery on Mars. And the surface liquid water. Yeah, we have several evidence of liquid water on the surface during 3 to 4 billion years of time. Again, whereas same we do have on Earth. We have the last ice race, but they are preserved. The volcanic activity of very early Mars is very well known. It was not again known in terms of that much. So though it is the plate tectonics, the volcanic history is that much known, but still it gives in good comparisons about the planetary bodies. So I was telling about the volcanic history. Though it is known on Earth, it is very well preserved on Moon and Mars. I was wrongly quoting this PT. To get into the first planetary body, Mercury. The Mercury, if you look at Mercury in a first glimpse, it almost resembles like our own Moon. It has, but the planet itself has no moon, and it is close, rocky, and it has a dense and is one of the smallest planet in our solar system. The eye-catching features that we see on Mercury is these subtler features. The lots and lots of subtler features. They are the impacts. They are the impact craters. They are in terms of lakhs, more than lakhs on Mercury. Now it shows there was a bigger impact. They are called impact basins. They are smaller impacts. They are called complex craters. And there are some fresh craters. This is the crater. You can see a white rays going out from this impact craters. You can see it all around there. You can see around this crater. So these are called impact ejecta rays. These rays indicates the impact is very fresh. During impact, the material will be thrown outside from the crater and they are splashed or they are spread all over to certain dust lines. If the crater is fresh, relatively fresh, or recently happened, these rays will be preserved, and you can see that one. Whereas in this crater, we will not able to see any rays. That means this crater is relatively old. This is the first sort that we got from the remote sensing observation of these images, that Mercury do have a good amount of fresh craters by seeing the bright ejectas around them. When I say fresh, the fresh is not in terms of days or years. It is going to be millions of years. Actually, in terms of the planetary bodies, the fresh usually refers to even hundreds of millions of years. That is fresh. Then relatively, this one is going to be older, few billion years. So there was a time difference of millions of years and billions of years. These bigger bodies, bigger impacts, usually form in the early phase of the solar system. That means around 4 billion years or just old to that one. Whereas these intermediate one and the smaller ones can happen anytime during the last 4.6 billion years. And another view of the planet Mercury, now you can see the rays. The rays are usually isotropic from the point of impact. That means they are spread radially outside from all the directions. That means the impact was almost 90 or less than 90 degrees. The impact happened, if this is the surface, the impact happened in this way. Whereas, and you can see the spread. For example, this crater spread, you can see the rays. The rays goes more than half of the planet radii itself. Now you can imagine if this much small crater can able to spread ejecta to this much distance, then there are so many impact craters and basins on Mercury. Then now you can imagine how much top crust of the Mercury has been modified by this impact. That's what this impact is, one process which completely shatters or alters the topmost crust of most of the planetary bodies. And here you can see the spread more. And Mercury is not only having the fresh craters. Being located close to the sun, the question comes to many minds is whether there were any colder regions on Mercury. Because the temperature is high, there may not be any colder regions on Mercury. But that was the initial understanding we had but when we have missions like Messenger, which has a dedicated missions to Mercury, when they looked at the polar regions of Mercury, the poles, what they have observed is there are some craters which are really dark. Like we know from our terrestrial remote sensing, this dark and bright is due to the sun angle illumination. The sun was illuminating from this side, probably. That's what you are seeing, because it's a depression and you will get a shadow here. And this is a steep wall which is facing the sun, so that it is lit by the sunlight. So due to this depression, bowl-shaped depression here, which is not seeing any sunlight from the day of its formation, and this will be of billions of years, all these craters. And there are some locations of such craters in the polar regions which are never seen sunlight from the day of their formations, or the potential cold trap regions where possible volatiles may be present. So the volatiles means even it includes ice. These are the regions where the potential volatiles can be maybe still preserved on the polar regions of Mercury. only on these craters, but not on these craters. Like these craters are exposed by the sunlight throughout some solar longitude based on their location. But whatever during the orbit around the sun, these marks will never ever see the sunlight at all. It means they are the real cold traps. So this is one big information that came out from Mercury, apart from the impacts which I shown in the last slide. In moving to Venus, if you look at the diameter of the Venus, it's around 12,000 kilometers. It's somewhat near to our own Earth, and it has no moon. Now comes the temperature. As I shared in the earlier slide, the temperature is around 740 Kelvin. And it is one of the hottest, and it has a very toxic atmosphere. It has an atmosphere, but the atmospheric pressure is around 92 bar. And here it is volcanically active. That means when it has an atmosphere, like usually in terrestrial remote sensing, we are aware about the atmospheric windows. Like in visibles, the atmospheric is opaque, so we can able to see the sunlight coming and going, which are recorded by the sensors, and there are few infrared radiations. So we can, these are the atmospheric opaque regions. But in terms of Venus, the atmosphere is completely blocked. The albedo is very high, but there are very few atmospheric windows, like in nanometers level, 1.01 nanometer, and few intervals of nanometers. We can see the surface radiation which can receive at top sensor or at the satellite sensor. This made the Venus to be studied in detail by radar images. That's what the Venus, which can penetrate the clouds, and they can look at the surface through the backscattering, and we can able to study in details about the surface features. And these features, what you are seeing, are possible lava flow regions in detail. This is the global image of Venus, where you can see, here you cannot see any big circular features like which I have shown in the last slide. The reason is, when I say this is volcanically active, and in the first few slides I have told last 1 billion years, it has only volcanic activity. That means most of the surface has been resurfaced by this volcanic flow. If any crater is there, that is going to be buried by these volcanic activities. Oh, this is one Magellan radar image which they have used to observe the crater on Venus. The circular feature is the crater, and the bright features which you are seeing are the ejecta material. And then radar backscattered signals, this rough surface will have high reflection. That's what you are seeing. This ejecta consists of big blocks of boulders called breccias, which are thrown out from this impact point of impact. And they are backscattered. That's what in the radar signal you are seeing very high reflections. But what is this? As I said, the surface is mostly of volcanic. When impact happens, impact has a capability to either melt the surface or bring the lava which is immediately below the surface. This could be either one of that, and this lava has flown from the point of impact towards the downslope directions. And this is also a lava. This is also lava, but this lava is relatively fresh and has a very rough surface. That's what you are seeing, a clear, more backscattered signals, whereas here it is relatively smooth. That's what we are relatively seeing it in the terms of darker planes. Same locations in another view, in a three-dimensional view. This is what we usually do in the terrestrial remote sensing, that to see how the topography is elevated and how the features are varying. This is one mons, possible a volcanic mons, and this is the impact. And you can see the scattered ejecta, which is having a breccias, and this could be the possible flow, the recent flow. Whereas these are also lava flow, but they are relatively older and they have become have lost that roughness over time. Then the question comes like whether if you have volatiles in the polar regions of Mercury, why not in Venus? But the same question happens when Venus polar regions are imaged. There was not that much craters, because If you don't have any craters, then you cannot bridge the depression. Through the depression only, you will get the shadow and the bright part of the crater. If the shadow part is not looking at the sun, then you can get the cold traps. But there are not that much craters on Venus, so the polar region is mostly the of OH volatiles. But still, the debates are there. There could be many other volatiles which may be preserved on Venus. And another example, it's again a crater with an ejecta surrounding them. The interesting thing over here is the crater looks nearly circular. The circularity index is going to be 1. That means it's a near perfect circle. That means the impact is nearly in a vertical direction. But why there is no ejecta preserved or formed in this part? If there was a low impact angle, like if this is the horizon and the angle is some 10-20 degree, then the ejecta will form in the opposite side. So you will not have an ejecta towards the incoming bolide side. Either it could be that, or if there was any volcanic resurfacing which occurred after this impact, that can also erase this part of the ejecta. So both the scenarios are possible, and it gives like that. If that is the condition, the volcanic activities post of this impact, when we can say that the volcanic activity is still ongoing after this impact has happened. That's what we have seen in the previous example also. Now, going to moon, so I'll be discussing in detail on moon. This is the near side and the far side. The striking difference what comes to mind is this near surface are called mare patches, which are mostly volcanic lava material which has filled the depressions, whereas this bright ones are the highland part, which consists of different composition. This is basaltic and this is anorthositic in composition. But when we say about the crust of moon, they are diverse from different from this part and this part, but still it is higher in the highland part, whereas it is more than 50-60 kilometers. But still, we see within the far side, volcanic material inside some of the craters. That brings the question: why there are very few patches on the far side of the moon when compared to near side? This is the one of the most discussed topic, that why there was a huge difference on the near side and the far side of the moon. If you look at same in terms of topography, this is the near side and this is the far side. The near side, these blue shades, the shades of blue, or the lowest elevation or the depressions, or having less elevation. This elevation data is again obtained by the altimeter. Like in terrestrial, we have orbital altimeters and aircraft altimeters to measure the height from the terrain, which will give the elevation of the surface. In similar fashion, the elevation is measured for the lunar surface from the satellite. If you look at the elevation details, these blue shades are less elevated. The shades of white and yellow-red colors are higher elevated. You can see that near side is topographically less elevated, whereas the far side is having a higher elevations. This itself says that this part is has preserved the old evidence, whereas this basaltic thing and low elevated regions where this volcanic lava is filled has resurfaced most part of the moon. But here again, the circular features, what you are seeing, all the circular features are impact craters. This is a basin, these are the basins, and these are the craters. Again, the moon is hampered by more than 13 lakhs of craters whose diameters are greater than 1. There is a paper by Robbins who has counted the individual craters, and he has mentioned this much craters. But I'll show some examples still how much more is there on the moon. To get a good high resolution image, the best image, one of the best images from LRO NAC data, you can see this is the Apollo 11 landing site. This is where the Neil Armstrong has landed. And if you remember, when Neil Armstrong landed, his footsteps was photographed, and it was said it will it will not erase forever, at least for some decades. The reason why it was told is there is no active process on moon other than solar wind interaction. That means whatever modification has been done to the surface, that will be preserved for few decades. This is a Apollo 11 landing module where the Neil Armstrong and others have landed, and this black line which you are seeing, it is the traverse where they have walked on moon, and when they are walking, they have disturbed the surface. This is the thing. The disturbed surface will take decades again to come to the adjoining tone, because it has been this surface this surface is earlier it was like this tone, but now due to the walking on the moon, it got altered and it got freshly exposed. Again, it will take some decades to come to this state. In last slide, I have told the craters are 13 lakhs, like whose diameter is greater than 1 kilometer itself, 13 lakhs. But now you see the scale is 50 meters. The scale plays an important role in remote sensing. Here you see the scale. It is going to be a roughly around 40 to 50 meter crater. What about this one? All the circles what we are seeing on the screens are impacts, the circular features. And you have different shapes, size, and diameters, and maybe depth, and the formation thing. You see some rays over there, small rays, so it could be fresh. You don't see any rays around these craters, so they are older. That means same region is seeing fresh and has preserved both older and fresh craters. There is no count on how much craters on moon till date, because it is very tedious. In this screen itself, you'll be seeing more than at least 500 craters of various diameters. Then comes Apollo 12. Now you see more clear. It's a bigger crater. It's called the Sarabhai crater and the head crater. You see the dark lines. The descent stage was here, and where they walk, you can track back them. And they have gone. And okay, the scale is missing. Sorry for that. The scale is again in hundreds of meters. They have at least walked for more than hundreds of meters, and they have gone. This is not at all disturbed. Coming to Apollo 14. Now you see the scale. The scale is 100 meters. This is where it has landed, and they have traversed more than 200 meters. More than that, they have gone. They have gone in between two craters. So how they choose to land here? How they exactly gone between these craters? They have very good preliminary remote sensing images of moon and this landing site. So the remote sensing images is the base for even choosing the landing site for all these planetary bodies to land there and do all the science related stuff. And this is the tracks which they have traversed. In more detail, the last mission, Apollo 17. Here you can see something else. Here the rover was used. You can see the when usually the vehicle goes on a muddy road, you will see the tire tracks between a gap. So this is one tire track, this is other tire track. This is how they have traversed. You can see again how far they have gone. Again, all the circles what are seen there are impacts. But if you look at this one, usually this is an panchromatic image, which is a two-dimensional image. But using the sun angle, we can able to discriminate whether the object is a depressed object or it's an elevated object. If you look at in this image, the sunlight is falling on the eastern wall. Suppose this is the north, the eastern wall of the craters, because this is sunlight, so it is elevated, and this part is having a depression. That's what the shadow is casting. And same thing happens over here. So the sunlight is sitting over there. But if you look at these points, you see a bright and a shadow. A bright and shadow. You are seeing a bright and shadow. You are seeing inverse to this. That means this is not a depression. It's an elevated object. Yes, this is an elevated object. Here you can see this is the lander module. You can see the light falling over this side and the shadows casting here, this side, which is again opposite to this one. That means This is saying that it's an elevated module. It's a module where the land has happened. That's what you are seeing here. That means here, these are the boulders, the small rocks which has popped out. It's not small. With respect to the scales, it is going to be in few meters. That's what you are seeing it. And they are popping out from the adjoining surface. And this side is facing sun and this is not facing the sun. So that is, these are the elevated boulders or rocks which are present on moon, and they are all while landing or while going to a planetary body. It is not only the depressions that cause difficulties, because if you land within this crater, it is going to be at least few tens of meters. So climbing few tens of meters is really difficult. So you should be careful about the depressed bodies and careful about these elevated bodies. Now, to coming into impact there on moon, look at this is the near side. Near side there was a crater, and far side I have shown it. Near side, what we are seeing is I'm seeing a faint ray. If you follow the cursor, you can see a very faint ray which comes from this crater. Even it is called Tycho, which we can see from our naked eye. It is visible. It's a very one of the bright crater located on the towards the southern side of the moon. Whereas this crater, as I said earlier, there are no rays. This shows that this is relatively younger when compared to this one. How these craters look like? This is how it looks like. So what we are seeing is an impact. You see that this crater is roughly 80 kilometers in diameter approximately, and it has a peak, and it has thrown out material. These are the materials which are thrown out during the formation. Whereas the other blue one, which I showed here, you see, you are seeing a contrasting in a panchromatic two-dimensional image. So the craters are relatively comparable size. What you see within the crater, here I'm not seeing any darker material, but here I do see a darker material. The similar darker material is present on the near side of the moon. Means this crater, after its formation, has been modified by some volcanic process or some volcanic material which intruded and deposited within that. But why it didn't happen? That's how the research goes. There are few craters which has magnetic material which has been filled with it, which was not filled. As I said, this is relatively younger and this is older. The one possible answer is at one time frame, the craters are possible enough to bring the subsurface material to the surface. And it depends on the place where they are forming. It's not only factor of time, it depends on where they are located. So this image clearly gave an attention that in far side also we have lots of mare deposits, like these mare deposits, which has been present below the surface, and they are exposed by the impacts. If you go back, here also the same, here also the same. So the impacts provides a pathway for the subsurface material to come and deposit on the surface. So what we are seeing is that this crater has a connection with the subsurface. That's what we are observing from this one. There are a few ways. There are other images like hyperspectral images called moon mineralogy mapper, where we can get the composition. And there are some thermal images where we can get the temperature and other rocky, how rocky the surface is, we can able to get it. And some radar images to look over the roughness. So moon has all sorts of images to get a glimpse how very good resolution we have, like in terms of terrestrial. This one is taken from this topmost spot. This is a small mountain called a peak, central peak, which forms at the center of the craters when they are bigger than 15 kilometers. You can see a small boulder. This is a rock, and you can see individual boulders over there sitting on top of this peak, and this boulder is casting a long shadow. So that means this boulder is really big. It is even more than 50 meters in diameter, in its length. And you can see other soil, small particles, like what you see on terrestrial remote sensing. So this made people to take the planetary remote sensing, because we have a very good very high resolution data sets. When we have our own Chandrayaan-2 image, they are very high resolutions and very good. Apart from impacts, there are large basalts, but they few have a channel where once there was lava flow happened, they were also present. But many of these mare basalts are from the subsurface through some of the fractures which generated in the target rock, and they came and filled the surface. So we will see some kind of channels on Mars or release called as release, but they are not fluvial origin. They are only of volcanic origin because there is no water or atmosphere on Moon. When this impact happens, the impact, as I said, it will not only form the crater, it will alter the surface. If the alteration is so extreme, the target rock, which is going to be present beneath the surface, will be melted because the impact comes with a very high temperature and pressure. The temperature will be few thousand kelvins, and the pressure will be few GPAs, few tens of GPAs. And this is one location which has been shown here. You can see again a dark material which has been filled within there was earlier depression was there, and this darker material has filled. There is a study by Ashley et al. Where they have found that this is the melt, the rock during this impact. The rock which got melted has thrown out and deposited within this small cone. So this is called as impact melting cone. This is a king crater on Moon. Now you can imagine, like, once I'm sorry for the scale, this is around within 100 kilometers. The crater has this much large amount of melt. I have told there are 13 lakhs of craters on Moon. Then now you can imagine how much impact melt has thrown on Moon and how they are deposited and how they have spread. Like globally, how the ejecta has spread. The melt is also spread along the surface of Moon. Going from equatorial to polar regions, the polar regions, as I said, for planet Mercury, where the polar regions have cool traps where the volatiles are present, the same concept holds good for Moon. The darker ones which you are seeing are the regions which never ever see the sunlight at all. That means they are the potential cold traps where even water molecules can be there. That's what this is a more interesting target sites to look over these permanently shadowed regions. These are called PSRs. And in southern hemisphere, they are in South Pole. There are a lot of them, and they are the potential regions to look for, explore whether any volatiles till date it is preserved. These volatiles are not on the surface; they will be just beneath the surface. So they are the potential things. The proposed next human mission by NASA is somewhere going to land at this point, near to the northwestern side of Shackleton crater. This is a place where it is proposed one. How that crater looks like? This is exactly this one, where the 90 degrees south, where all the longitudinal lines converge at this point. You see how they are looking like. The long-lasting shadows. This is the crater rim, which is the elevated part. The one which I'm showing is this part. The inner is given as dark. You see a complete dark. Complete dark. No sunlight will fall in at this part or floor of this crater. No sunlight. From the day of its formation, no sunlight has. That's what they are, the potential cold traps to be preserved till date. One of my students did a study in an internship program about this crater, where the star mark is the potential landing site proposed. And, this is the rim of the crater. You see the inner part. You cannot see anything from within the thing, from within the interior of the crater. That means they are not seen. But what you see is the boulders the exposed rock, which got weathering due to space weathering, and they are got exposed within that. So there also modifications are going on. There are boulders, space weathering, all those things are happening. But still, they do preserve the volatiles which was present within them. We do have our own Chandrayaan-2 landing site also. So this is the proposed landing site for the Chandrayaan-2 mission. The red dot, which is again around 70 degree, and it is the one I showed which earlier, the Shackleton is somewhere here, exactly at 90 degree. So till now there is no mission planned to land at higher latitudes. The first proposed was Chandrayaan-2. Maybe Chandrayaan-3 will land in somewhere in this part. What do we see on Chandrayaan-3 is it is a very old surface. That is one of the reasons to choose them as a landing site. The landing site is around a date of 3.7 billion years, and there are many craters. I said this is one crater where the arrows indicates the ejecta which is thrown out. So if you land here, you will get the material from here. How? When this impact happened, it might have thrown material up to this. If you see these arrows, this also falls within this arrow. That means you may contain material from this region at this part. When we dated, when we looked over the craters within the proposed landing ellipse for Chandrayaan-2, these are all these circles, all the circles which you are seeing, the circles you are seeing are impact craters. When we date them, what it gave as like they are 3.7 billion years old, and there were 23,000 craters within this ellipse. Now you can imagine, like within a 15-kilometer ellipse, you are having 23,000 craters. Now think about the entire moon. It is going to be very huge. To the final thing of moon is the recent Changi mission, where they have rover landed and they are looking over the surface. You can see all these rocks, and these rocks have fractured because they undergo thermophysical weathering, like day and night temperature change itself is sufficient to cause the rock to weather, and they are weathered and they are exposed, and they probably formed during an impact. The materials will be grinded like this boulders, and they are thrown out. The advantage of this rover and lander mission is, along with remote sensing, how on Earth we do a field visit for the comparison. This rover and lander images will provide a good hand support for the remote sensing images. So we can go in hand with together about how the surface looks like from in field, but we are doing the field in another planet or satellite body, and from image, the comparisons really gives a good information about how the surface looks like. And there are other examples of how the rocks are distributed on the surface of moon, where the Changi-3, the Chinese rover, has landed. We're going to the last part of the talk, the Mars. If you look at Mars, the Mars is roughly half of the size of Earth. It has 2 moons. And look at the temperature. The temperature is 210 Kelvin. That means the current temperatures are colder, and the pressure is around 6 millibar. That means the current setting of Mars doesn't favor for direct living conditions, or it cannot host the surface on surface the liquid water. The pressure and temperature is not favoring, but on polar regions we do have ice deposits, ice traps, and other active process which we do see on Earth. This is again the topography of Mars, how the elevation of Mars is varying. You can see this blue shades are low elevation, where the topography is low. The shades of red and white are the highest elevation. Now you can see if I put a hemisphere line, northern hemisphere, in average it contains low elevation. The southern hemisphere in average contains higher elevation. So this is the first thing we observe from Mars. and the boundary which separates this shades of blue and with other colors is called the dichotomy, because there are two regions are there. That's why it's called dichotomy. And the interesting thing on Mars is like how the migrations happened from Moon to Mars is, in Moon there is a dearth of water. There is not that much amount of water present. But on Mars, there are very good evidence preserved that once Mars was rich in water related activities. To get a quick glimpse of Mars, if you look at these white patches, this white patch is roughly more than 21 kilometer elevated from the surface. So from this line, it is 21 kilometer elevated. It's a mountain. This mountain is 20. We have no analog for this mountain on Earth. And this is the tallest volcano called Olympus Mons on the solar system. Now you can see how big the Mars features are. The other one, this is called Vallis Mandaris. It's a valley. It's an opening. It's with a depression. You can see the blue colors present within that. That means they are topographically low. They are the opening, and the length of this valley is around, from up to here it is 2,500 and another 5,500. So the total length goes to 4,000 kilometers. Again, the Grand Canyon on Earth is roughly 400 kilometers. We don't have any analog for such a big opening on Earth. And then comes the impact basin. This is called Hellas Basin, where the diameter is few thousands and so big, and it is deeper. Again, we don't have any analog for on Earth for this kind of bigger basins. And if you take these are all the volcanic regions. These are all the valleys region, and these are all the polar regions where the ice was present. I'll show that. When you look at impacts, again the craters, that what we do see that different from Earth is, we do see a typical ejecta pattern. Means this is the material which has been thrown out from this impact. When this impact happened here, the materials are thrown out in all the directions. But at the end, you see there was a small thick deposits at the end. If you look at all this part, so this was hypothesis like how the thick deposit. Usually, when impact happened, the material which is going to be thrown out at the farther distance, you will have a very thin material, but you do see a thick material. That means it has interacted with something. People proposed that if there was any volatiles there, and it is like when you mix sand and water and with or mud. When you pour mud, you will see these kind of deposits. They will go and form as a small chunk. This brings the attention like whether this region before this impact, this region is whether volatile rich that was used by this impact. You see this, there is another impact. This is the ejecta which has been thrown out. It looks like a typical butterfly pattern. And the crater is also not circular, it's tending towards ellipse. That means it's a low angle impact where the butterfly shaped ejecta has been seen. That gives an idea that impacts are occurring at different angles. And during that impact, the material thrown out also have a different effect. So from the ejecta spread, if you do remember on Venus, I have shown one example where only one side there is no ejecta. So that may be one evidence for low angle impact, or they got resurfaced. And the other small features which you can see are the impact craters. The other things on Moon, the people work on the present day activities are how the gully channels form. That means this is a channel, a very small channel. You can see the scale, it is 100 meters. And like how we do on Earth, the temporal studies, whether there was any landslide happened or any channel formation or any change line, coastal change line things, we will use the temporal image. For Moon and Mars, we have good amount of temporal images. This image is taken at 2010. Look at this line. There was no such channel, but on 2013, we found a few channels. The features are exactly same. We have control points, and we can have a good georeferencing, and when we overlay, it shows the new changes as well. And it is not only for the thing, we have dunes like what we have on Earth, the terrestrial dunes. The dunes, due to the aerial activity, the top surface of the dune shapes patterns will change. See, this is one pattern what we have observed in one time frame. You can see this blue one. The blue one has a straight line and an inverted V. But after some times, what it has swapped. That means it has been modified due to the wind activity. This gives that the current Mars is an active in local scale. It is active. It is very active, and modifications are going on. There's another example where there are diverse amounts of dunes. Like this is a false color image. Like similarly, what we use for our terrestrial remote sensing for the vegetation things to enhance the features. Here, the false color images are applied to enhance the features what was present over there. These are all the dune deposits, and they you see the pattern. They are just following this one. Exactly, this says that wind is blowing. It tells about the wind activity, and they are getting modified, eroded, and modified over time. This I showed the largest volcano again in 3D. Usually, we are more interested in terrestrial things to generate three-dimensional image and look for it. The same thing we can do for planetary images. Especially for moon Mars, there are plenty of three-dimensional images available where you can generate. This is the mountain which I was talking about, more than 21 kilometers high. Now you can see how big it is. And top, you can see some collapse features, some craters, some flows at the foothills. You can see some flows, etc. The other feature on Mars, like if you look at the present day activities, is the called recurring slope linear. This is linked with the brine. You can see like it is exactly how we use the temporal images. This is do we have seasons on Earth? The Mars do have. That is represented by solar longitude, and they are looking into Martian years. Like one Martian year is equal to 2 Earth years. It's because of the rotation of Mars around the Sun. So a Martian year 29 means it is 2 years of Earth. 30 means 2 years of Earth. And you see, at 29, there was no linear formation, but when it comes to Martian year 30, you can see the features developing. This is reported to be of brine, a salt-related flow which occurs due to absorption of moisture and air, and it develops. And it has a very good control on the seasons. This is one of the other active processes on Mars. Apart from that, to look at the poles, as I said, the poles region contains lots of volatiles, like Moon or Mercury, where we have only within craters. Here, there is no issues at all. On just below the surface, just few centimeters below the surface at polar regions, and sometimes in the seasons, you see ice deposits on the surface, but they will be distribution of both CO2, carbon dioxide ice, and water ice. They both are present in a mixture form. And to coming towards the final slides, the Mars has fluvial channels. How they are saying. This is one topographic image that usually when we see a topographic image of a terrestrial river, you will see a near sinusoidal feature, and you will see some islands in between that. You would have seen when the water level was low, the sands will get deposited on that, trees or vegetation will grow. And when later water comes, it will try to bifurcate that island, and that's what we see on most of the terrestrial rivers. Exactly that was seen on this part of the region. Again, it was shown that the channels are associated with craters. They are outside, but that is not the scenarios. They are present within the craters. Like we do good mapping, like in the terrestrial things. Similar is there for on planetary science also. Otherwise you do a detailed mapping, you will not get about the idea where they are located. Like these blue lines are the channels. and the shades of black with a white boundary are the fan deposits. These fan deposits are related with water-related activity. And the same crater, when you look it over the topography in a three-dimensional thing, you can see this is the rim, this is the depression. Again, this is the elevated part. You can see the contours. There was a difference in elevation. And you look at this line. This line comes from top to the bottom. Exactly, it goes from 1600, minus 1600 to minus 3000. So from top to bottom, it is going. So this is channel forming, and it is forming a deposits over there. And on the floor, do we have deposits? What is there on the floor? This is what's observed on the floor. You see, on Earth, the channels are sinusoidal. When the water flow, it forms flows in a sinusoidal thing, and then it will convert into oxbow, or when there is more water and variations happen. But the reverse goes in a sinusoidal thing at the foot, the termini, it will deposit the alluvium materials, and which forms as a fan. This feature, you can see the sinusoids ridge and the fan ridges. But the thing is, we're not seeing a typical fan. What we are seeing currently is an eroded fan. This is the ridge of the fan. The ridges are forming because when the deposits, the coarse grained material, the blocky material forms this ridge, and the associated with fine grained materials. Due to weathering, the fine grained materials will be eroded first, whereas this ridge, the coarse grained materials, are preserved for a longer time. And when we look on more in detail, we are aware about the avulsion, which gives there is a change of path of water. When there was one side, it was blocked by topographically high object, so it will try to take the least path, and where there was a topography supports them. You see, there was a ridge, was an eroded ridge, and then there was a sinusoidal channel. The avulsion node always has a common point. The water, it will start deviating from that node. That's why it is called node. And what we are seeing on Mars is a similar kind of avulsion. That means the water was once flowing in this path, and later, due to sediment deposits, it just migrated and started flowing in this. So these are the evidence where we can strongly confirm that water was once flowing on the surface of Mars. It's not only water, as I said glacial volcanic activities are there. There are regions where this now you can see the color scale. This white one is roughly 2,100 meter elevated, whereas the shades of red is in the negative terms of 900. So within the crater, you will see lower part, whereas in the other sides you are seeing elevated. That's a mountain. It's a mountain, and it has an impact. All these circles are impacts. Again, the channels, what you are seeing. So the combination is there on a volcanic dome. There's a dome. From the topography, you can get it's an elevated part. Impacts are happening. Then channels are seen, and the channels are also forming the deposits within that. That means in one place itself, all activities are saying like a volcanic dome. Then you can see channels, and this ridge, they are related with the glacial things. That means once Mars was rich in all sorts of activities, what we do see on Earth, like fluvial, glacial, and all. This is how the fan. Again, you can see a fan deposits over here, and the ridges. These ridges are again the coarse grained material, which I was discussing in the last few slides. Okay, the last few slides, like we'll end with the current rover which landed on the Zero crater, which is called the Perseverance rover. Why they have landed here? Like in last slide, I have shown this is the crater where the rim was breached and the sediments and water came and deposited the fan. This is what we are seeing. Exactly in the current landing site also, we are seeing a channel, and then this is a delta deposit. Like terrestrial deposit, delta deposit, yes, it has once hosted a water body, a standing water body, and the sediments came and deposited within that and formed the delta. And these color shades reference represents different minerals over there, and this is what the proposed landing site for the 2020, and the rover has started traversing it. I showed two examples of the current rover due to time. I'm almost there. This is one within the Gale crater by Curiosity rover, where you can navigate dune. It's a dune. You see this dune, the material is sliding. It's a rover image. It's a rover image, not an orbiter image. Within the Gale crater by Curiosity, you can see the materials. This is a dune, the top of the dune getting slided over there. What is the resolution we have? You can see the pattern on the dune, and that got disturbed. That means a very current small slide, as landslide has happened. That's thrown out this one from the dune, and a longer one. This much detailed resolution we have for rover. So that means now you can tag the rover image from your orbiter, and you can do temporal and other sorts of studies. What about the perseverance? You see again dunes, rock, individual rock. You see the rocks tilted at a different angle. They are maybe the earlier deposits or even sediments. They got consolidated, and the fine grains are getting eroded below this. You can see some erosion, all these things. They are getting modified. This is one of the recent image. And the final image to end this, we have very high resolution from these are the rock blocks, fine grain sense, very fine grain sense. In the small shadow part you can see, and you can see how the rock is getting weathered, and how they are getting weathered, and how after sometimes they may break. This is what happening on the current scenario at the zero. Summary. So it provides a good opportunity for understand the planetary bodies. So more and more planetary remote sensing satellites is really helping to understand how diverse the planetary bodies are there. So with this, I will end. If you have any questions, ready to answer. Hello.
Thank you so much, sir. A wonderful lecture, interesting lecture. Definitely, I think students would have enjoyed, and all the dignitaries, experts available here would have enjoyed this lecture, I believe. And I request the students now to interact with the chief guest today. You can also post your question in the chat box.
Currently, I'm not seeing any question in chat box. If anyone have any questions, they can ask.
Palanivel,
Yes, sir.
can I have a couple of questions?
Please, sir. Please, sir.
Just initiate.
Please, sir.
Dr. Vijay,
Yes, sir.
thank you. Thank you very much for your nice lecture.
Thank you, sir.
It has so many new information, and compared to your previous lecture, which you delivered a couple of years ago,
Yeah.
it shows that you are doing great type of research work on our footing. It's an excellent piece of information as far as lunar and the Mars is concerned. In fact, I have a couple of observations, some doubts rather. We have shown some pipe-like things, isn't it? They are lava tubes, similar to lava tubes. Similar to lava tubes that have been located in parts of Maharashtra in technical mechanics.
Yeah.
Are they lava tubes?
So you were asking in Maharashtra or on Moon?
No, moon. Moon you are showing some.
Yeah. So there are lava tubes on Moon. There are some collapse pits, but what they have seen is it's like a cylinder one. they have seen a cylinder collapse. But
Okay,
like
okay.
what we Earth on having an horizontal cylinder, that was not seen. Yeah, big
Okay.
kind of feature has been observed. Multiple lava pits
Only only in one place or number of places?
number of places.
Very good. But since there's no atmosphere, my another question is that this lava tubes is okay. Then since there is no much atmosphere related activities there and processes, why there are no ejectors in any of the craters? Why there should be much, isn't it?
Yes, sir. Okay, the reason for that is many of the craters, the bigger craters or the complex craters, are very old. The ejector has been modified by space weathering. On Moon, the important thing that happened is micrometeorite impact. A very small particles will come and hit the surface with very high velocities. When they come and hit the surface, they will just alter a few centimeters. And such kind of micrometeorite impacts are occurring throughout Moon for billions of years. That's what the older thing, and the solar radiation. Apart from that, solar radiation also plays a role. That alters the surface, and that's why we are not seeing many craters with preserved ejecta. But we can distinguish ejecta, but we cannot able to see the rays. The rays will fade away first.
But in one place, one location, you have shown the vast ejectors in very white or light gray tone.
Okay.
The white tone. That is in from Moon only, na? Very large area covering.
That is from Venus. The initial one is from Venus.
Venus.
Okay, the Venus is backscatter because it's a radar related thing. There, along with ejecta, we have a lava flow also. When lava flows, it may be a coarse grain. In backscatter radar signal, it will be bright.
Okay. But now then, so much of impact and has taken place. Are there any tectonic impressions or tectonic reflections on the Moon or on the Mars
Okay,
as rebound or reflects from them?
Okay, so
Because
that's,
heavy explosions have taken place.
yeah. So that's a question still yet to be answered. Like few indications we see for the tectonics, but not related to plate tectonics, or there are multiple plates kind of thing. That is still a question kind of thing. But we'll see some kind of scarps, wrinkle ridges, which is buckling during the movement of lava over a large area. And there are some faults like quacks. Moon quack and Mars quack are there, internal quacks that will shatter the surface. So we have evidence like that, but not the significant evidence like what do we have on Earth. That is not got in detail.
Whether any cores have been put in the craters, center point of the craters, to examine whether any tectonism has taken place there?
No, at the center of the crater, it will be highly fractured, and if it is bigger crater, it will form a peak within the crater, and it will be elevated from the surrounding surface. In that way, the region is going to be heavily modified. But I have shown an example where there was a dark lava material filling the crater. That how it came is because of the impact fracture. So we can say the fracture is really happening there, and it is altering the surface. But again, the evidence is not that much consolidated to stamp, but yeah, we can say it is very difficult. It's challenging.
No, that again, the peaks in the center, the core part of the craters are due to the elastic rebound of the.
Elastic rebound.
When elastic rebounds are there, you say there are a lot of fractures.
Yeah.
But whether this fracture morphology and other things have been studied.
Yeah, they are studying, sir. Usually, when impact happens, two major fractures will happen. One is radial and concentric. One of my PhD student is studying about that fracture, exactly about that fractures. Till date, there is no information about how deep these fractures can penetrate and how they are varying throughout the craters. We on surface, we do the radial fractures. If you look through the remote sensing, we will usually see the fractures by alignment of tree, where the water will percolate and the vegetation will start growing. If there was an alignment of tree by an non-man-made deposits, then it is obviously a fracture. But in terms of Moon and Mars, we don't have that evidence, but we we will ourselves look for these inner fracture patterns around the craters. That's my current PhD student work.
By and large, they are only radial cracks. Huh?
The concentrics are there. The concentrics are not visible. The concentric will form mostly beneath the surface, and they are interconnected. The radial and concentrics are interconnected, and it also have a role how the target rock is fracturing. So it is apart from that radial and concentric, there was a fracture on the target rock.
Actually, when these type of impacts are taking place and impact craters are formed, the strain phenomena will be different. They're called a constructive strain.
Yeah.
The constructive strain, if you could bring some evidences for the fracture morphology, then we can see, yes.
Yeah.
From that, you can bring out any constructive strain was there. And from that strain, can you arrive at the stress field?
Yeah.
The orientation of the compression, orientation of the rise of the central plug-type material and all.
Yeah.
Anyhow, we will not go along with that. But as far as Mars is concerned, could you get any anomaly in the drainages which could indicate some basement faults or faults?
Okay.
Next, any anomaly?
Yeah. So the one image, if you want, I can share the screen and show that one. This one. This is a big graben or a fault. It's a fall. You are seeing a straight line fall, and from that only the channel has been come. So this fault is deep rooted. It is very deep rooted. That's what it has touched the possible groundwater or the ice or the cryosphere, which got melted or came out and formed this channel. Exactly the fractures or the potential zones where we can look for these channels.
Yes. Good, sir. Thank you. Thank you.
Yeah.
Thank you. And,
Yes.
Thank you, sir. And
Sir, in the chart, there's few questions are there.
there are some questions.
Can you be able to answer that? Sir, shall I read it?
So I have one
Yeah.
question.
Yeah. You can read.
Can I ask?
Yeah.
One student has asked to do all the planets rotate in the same direction. And
Yeah.
direction
Not all Venus and Uranus. They do differ. Yeah. Yeah. Yes.
And they ask
Continuity of the
about the asteroid.
Sorry.
Asteroids. They also ask about the asteroid location. Sorry, direction.
No, I'm not audible here.
If all the planets rotate in the same direction, then what about asteroids? It is in the
Asteroids. No, we have millions of asteroids, so it is very difficult to find their orbits. They will not. They all orbit around the sun, but whether you're asking their individual orbits or rotation around the sun, I think most of them goes around the sun only in the same direction. Most of them.
Okay, and another student, she has asked, how much does the solar wind affect the lunar surface?
Okay, so this is earlier. Even someone asked why we are not seeing ejecta. I have shown only fresh few craters with the bright rays all around surrounding the craters. Why the other craters are not having? The solar wind is one main reason on Moon, which has an effect in making the soil to mature. That's what we are not seeing it. Surely it has a very big effect in terms of.
Dr. Palanivel.
Yes, sir.
Thank you for the lecture. I will take
Yes,
off
sir.
because I have some other one.
Thanks a lot, sir, for gracing this occasion by your presence.
Thank you, Dr. Vijayan.
Thank you, sir.
Thank you, Dr. Sambandam, for participating on all our events.
And,
Yeah, I have a question. Can I ask?
please.
Okay. For the planet Venus, we know that it has a very thick atmosphere.
Yeah.
So for any bolide to impact on the Venus surface, it will be very difficult, right? So in
Yeah.
that case, Venus might have had less number of craters.
Yeah.
And okay, there is possibility that the craters are erased by the geological activity. But
Yeah.
given the thick atmosphere, Venus would have relatively had already it started with less number of craters. Is that so?
Yeah.
Or the atmosphere came only after the impacts?
Yeah. To answer that, the atmosphere, what we know is the 92 bar is the current atmosphere, but we don't know what is the atmospheric pressure during the earlier stage of Venus. If it is that much thick, yeah, the number of craters going to be formed is very less. If at that time the atmosphere is not that much thick, then even smaller craters form. There was a study that what kind of craters can be preserved or form on Venus with that kind of current atmospheric. There's smaller than 2 kilometer craters cannot form because those bolides will be burnt in the atmosphere itself due to the drag. Even Mars, even Venus completely lack impact basins, which will deflect the atmosphere. So the main target to look on Venus is where the Venus impact basins have gone, whether they were there and they got modified or infilled by the volcanic activity. That's the big question, and still it is an open question because whatever be
But
the
the
atmosphere.
95 bar, or if Venus had a higher pressure even in the past, then that will slow down the velocity, right, of the incoming bolide.
Yeah, that will slow down. But when we talk about impact basins whose diameters are greater than 300 kilometers, and we have on Moon Mercury like more than 300 diameter basins, like at least in numbers of 10, 12 kind of thing, more than 10. But Venus, we don't have that much. That means it was there, but currently it got modified by the volcanic activity. It was not preserved or it was not exposed. Whatever be the scenario, as I said, the smaller impacts, it's very difficult to surpass the atmosphere. But the basins in the older epochs, surely they have impact. Like on Earth, we don't see any impact basins, not much, more than 300 kilometers, because the active tectonic process and other process has resurfaced. Maybe the same phenomenon happened on Venus, but from Earth, from past, we have the same atmosphere, not that much, but still we are seeing like 160 craters only on Earth. On Venus, it is around 700 plus kind of thing.
Okay.
Excuse me, sir.
Yeah.
So good afternoon. First of all, it was a very wonderful session.
Yeah.
And so last year there was a weird long cloud over the Arcia Mons peak, I think, of the southern pole of Mars.
Okay.
Do we have anything to say about that, sir? How it comes and it occurs seasonally every Martian year.
Yeah.
So
Okay, so
what causes that? Is it from the volcano or any other reasons behind it?
Okay. There are some studies. If you look at the terrestrial things around the top mountains, you will see some clouds circulating over there. I forgot the name, but similar kind of clouds have encircled around the Arcia Mons and the Tarsus regions of Mars. They have found what kind of clouds it is. Mostly, they are saying it is an water cloud. It is not the other thing. The most of them are water cloud. Like similarly, what do we see on Earth? But seasonal dependence, yeah, they are seen in some seasonal dependence. But the formation and why they are forming at a particular time and not at other time is still a question. Like why only around those mountains and those seasons? That's what they. There are a few couple of papers. If you just mail me, I can get that papers to you. We can have a look in detail more on that.
Yes, sir, sure. And is it water cloud, sir? But
Yeah.
Martian surface has CO2 atmosphere.
That's the thing. They are water clouds. They are observed water clouds.
Does it occur only in that region, or Mars has
No,
varied water clouds?
you
over
have
it?
moisture. Okay, if you go to higher latitudes, we have did a study where if you in higher latitudes, if you just in the crater walls, when suppose the crater walls got exposed, there you can see water ice that we have studied. That means Mars has water ice and CO2, both the ice. Even in higher latitudes, if you go, you can see both these ice deposits on the surface. But when the season changes, they may sublime. Directly, they go to the sublimation stage. but both the things are present in Mars, higher latitude. But this one, it was told water trough.
Yes, sir. Thank you for your response.
Dr. Muthamil sir,
Sir, is there any other?
one or two more questions are there. Can you help them? Help sir, Jane sir to understand that.
Yeah,
Can you
sure.
read?
One fellow has asked about the maritime soils.
Okay, yeah, I just saw. And how the capacity of soil in Mars for hold water.
Yes. Okay.
Yeah, a difficult question, really. The soil looks like, if suppose the spectral studies, hyperspectral studies have shown there are lots of clay deposits like smectites, hyalinites, carbonates. Those kinds of sands are there. On Earth also we have a lot of smectites. On smectites there may be vegetation growing. That means small grass or whatever kind of thing. In small, very small kind of thing. If that even if you have look at the Deccan basalts, they got weathered and their vegetations are happening. So Mars also has basalts, olivine rich basalts. In that sense, it is weathered. Yeah, it can be, but how it consolidate, how it can hold it. It is not only the soil that we can make them to grow. The soil usually should help them to grow, but the other conditions like the pressure, the temperature, and other factors. It's a good environmental record to grow it. If you look at, there are some studies in the International Space Station, like if you go to the outer atmosphere in your microgravity environmental conditions, how the plants are growing, how the roots are growing. Yeah, they are doing it, but there is no study till now because you will find analog for Martian soils. If you take smectites here on Earth, it is there. On Mars, it is there. But here it will surely it will grow if you add some modify it will grow. But on Mars, we don't know about how it is. There is one attempt by Changi mission on Moon. They took a soil with a seed to Moon in one of their landers, and after landing there, they have seen the plant started growing. They have seen that leaf coming out. That they have did it, but there is no news about what happened after that. Oh, this question is really interesting. How the plant grows. The future we have to see it. Yeah, porosity. Porosity, yeah, it is around. It varies. It depends on when impact happens. What it will happen is like it compacts the soil where it is. So there it will be going to be different. So it varies around the thing on Mars. Then some have asked about internship. Yeah. So we are usually do two internship. One is at summer internship. They'll announce in their website. You have to just apply with your CV and through your head. I think your head will readily do it. Just based on marks, I think they will shortlist. And the other thing is you can do projects. Your final year M.Sc projects you can do. Again, they will do for a call for, and you can apply through it and you can do it. Or if anyone really interested, you can contact few people there are PRL and you can do with them individually. It depends on highly your interest, how active you are. So if you approach individually, you can do it, irrespective of through PRL. That is one way. I'm opening the other way. You can do it. So myself and there is a person called Dr. Bala, everyone and my colleagues, many are there. You can approach them.
Palanivel sir, I think question almost over.
Our Dr. Samandam sir, I request Dr. Samandam sir to give your suggestion for. Sir is trying to unmuting mic. But it is not unmuting, sir. Still it is in muted condition. Okay, sir. Okay. And I request the professors, Kumanan sir is also with us to say a few words. Sir, still your mic is in muted condition, sir. You need to unmute. No, sir, we are unable to hear even now.
Is it audible now?
Yes, sir. Please, sir.
Okay. Thank you, Dr. J,
Yeah, thanks.
for your wonderful informative talk. So students are highly benefited by your talk, definitely. Whether they are benefited or not, I am myself. It's a new area of research, which I could not take up because I was very much interested when I was in the last phase of my service, particularly to lunar projects. But somehow our center was happy to have a project on the lunar. Dr. Sarabhai has taken up a lunar project, and one student has submitted PhD also. But the informations what you have given for the, particularly for Moon and the Mars, really very huge informations. Definitely a large openings are there for the students to take up projects as well as research. And in that sense, I feel that this information what we have given is really going to help us. Of course, the clarifications are there already, but as far as myself is concerned, okay, that I've got a lot of positive informations. But the questions I don't want to ask at this stage because I myself has to understand the lot of details. So I am in the preliminary stage. So I think that it is not correct on this stage to ask some questions. But anyhow, I must thank you for your kind patience and preparing a very informative slides with beautiful descriptions. So I thank you for giving a good talk for the benefit of our students. But students must be very much thankful to you also, sir. Thank you very much.
Thank you.
Thank you, Dr. Palanivel and Dr. Muttal. Thank you.
Thank you very much, sir. Palanivel, sir, is there
There
any
is
other?
one more question by Tahira.
Okay.
Can you?
Okay. Yeah. So the microbial evidence on Mars. One of the objective for Mars 2020 rover, which I showed in the Zero crater, their objective is look for biosignatures. The instruments which they have sent it will help to understand whether there was any past evidence preserved there, and even they selected the landing site so precisely that they have chosen. I have shown it is a delta deposit. That means once the water was there and the sediments has formed and the sediments has been deposited stratigraphically on that region. That means water activity has been there, and we are biased with water. With water means there should be some biorelated signatures may be there. The objective of that rover is exactly what you have asked. Maybe soon some results may come, but not exactly in the microbial form. Maybe in towards the biosignature things. That until this mission, we'll come to know some results surely. You can follow the March 2020 rover. I can share the link with you guys. You can go and have a look on March 2020 rover images what they have observed, and the one which I showed in the last two slides is exactly from there. I'm just posting the website link. You guys can get it, or you can mail me.
Yes, sir. And sir, particularly some microbes are will live on the carbon dioxide atmosphere and environments. So that may be a chance now, sir.
Yeah,
Maybe.
exactly. There are some studies on Earth where they have seen these microbial in harsh conditions. You see, in hydrothermal vents, also something where there, so which is in extreme conditions. So similarly, we have both sorts or all sorts of ice on Earth, and we are seeing microbe-related things on all kind of conditions. Recently, I came across an article where in Antarctica, in rocky surface, where there was an algae growing out, which should not grow over there. That means it is an indication of climatic conditions. That means huge variations are happening. As I said, it can be there, but until otherwise we found the evidence very strongly towards that. The best way is what currently we are going on. Go for a region where you anticipate such bio-related activities are possible. And not only this 2020 rover, where the Gale crater, the Curiosity rover has gone. That is also targeted where there was once a lot of water activity was there. So all the targets on Mars are oriented towards understanding or explore whether any possibilities of such bio-related signatures.
And yes, sir, I have another question. Can I ask? Is that time consuming?
Yeah, you can ask.
And so generally in regard with moon, we are more focused with the poles and the south pole, the moon. Is there any phenomenon like that or any suggestions like that for Mars?
Okay. For moon, the interest is earlier it was on equatorial region. The Apollo missions went to the equatorial regions, and now if you look, the focus is towards poles, especially on the southern poles. As I showed in my slides, the southern polar region hosts lots of volatiles, even OH, water molecules, but beneath the surface. But the amount quantity is going to vary, and the people are interested to test what kind of volatiles it is, what other volatiles are present, and how they are distributed. Whether it is going to be, whether we cannot directly utilize it because the amount is going to be different. But to understand, we need to first explore. So that's what more people are exploring. And other important thing is the moon has a lot of resource for ilmenite. It is one of the material, and which is a mining material. And even people are thinking there are missions how to utilize the moon ilmenite for our terrestrial use. And going to South Pole is, as I said, it is nowadays more focused. Even the proposed 2024 human mission, exactly it's on the polar regions, on the South Pole, to explore and understand about the volatiles. That makes the shift or interest towards the lunar South Pole.
But it's generally hard also to reach the poles.
Sorry,
in regard with the missions.
Sorry?
And it is generally hard to reach the poles, no, sir, in regard with the.
Yeah, that's what earlier they didn't.
Even Vikram was a failure with our missions.
Yeah, so earlier we didn't win. Now it is good to go take risk and explore new regions. That's what going towards poles. Even going towards Earth poles, Antarctica and Arctic is not an easy job. It's very tough. Going to polar regions of any planetary body is really tough.
Yes, sir. Thank you for your time.
Yeah.
Now, if there is no more question, then I invite Dr. Muttamil sir to give welcome on this one.
Thank you, sir.
Vote of thanks. Now, please.
Good afternoon, one and all present here. I hope everyone enjoyed the talk given by the Professor Dr. Vijayan. Even I can say he has mesmerized by his excellent speech about planetary science for more than an hour with a lot of images. So today we are celebrating the National Remote Sensing Day. Actually, it has to be happen on every year on August 12, on the occasion of birth anniversary of Dr. Vikram Sarabhai. He is the father of our Indian space program. So on this occasion, we had a wonderful lecture by Dr. Vijayan. So on behalf of our department, I convey my heartiest thankful to Dr. Vijayan on behalf of our department and also the faculty members from the Department of Remote Sensing, Bharathidasan University. I also very happy to convey my gratitude to each and everyone present on this platform. Today, the maximum limit has reached more than 100 participants were there on this seminar, and also few students were in the YouTube link also. So my wholehearted thanks to Professor S.M. Ramasamy, Dr. C.J. Kumalan, and Sampath sir for spending their valuable time with us, and also had a fruitful discussion with Dr. Vijayan sir. So in this occasion, I extend my thanks to the faculty members of the Department of Remote Sensing, Dr. A. Balukar sir, and Dr. C. Lakshmanan sir, Dr. D. Ramesh sir, and Dr. J. Sarabhai sir on this occasion. So without the audience, any meeting, it may be a political meeting or it may be an academic meeting, it will not be fulfilled. So I thank the students community and the research students, those who have attended the half day seminar, and I convey my heartiest thanks to them. I extend my thanks to Geology Department HOD Dr. Saktive and Geography HOD Dr. Jagan Kumar, and the other faculty members from various departments who have attended on this seminar. Students, finally, I would like to give one information that if you take 15 or 20 years back, if I say I am going to map a rock type, that means lithology, on the surface using satellite imagery, people used to laugh on this remote sensing. Even the geologists from various hardcore departments, because they used to say, by seeing on the hand specimen, we could not able to identify the rocks and minerals on the surface. How you are going to interpret or how you are going to identify the lithology through your satellite imagery or aerial photographs. But see, the time has changed everything. Today, we are able to identify, we are able to interpret the rock types and minerals and other possibility things from various planets. By seeing today's lecture given by the Dr. Vijayan, you could understand how we can utilize the knowledge which we have gained from the mother surface to the other planets. I know that few students from our department itself, they are doing major and mini projects in the planetary science. So I also encourage the other students or upcoming students to use or utilize the facilities available from the PRL and the guidance from our Vijayan and other colleagues from their department. You can use them for your project and other academic activities. Finally, I would like to thank everyone on this platform to have attended the wonderful seminar and the mesmerizing seminar given by the Vijayan. Thank you, one girl. Thank you for the opportunity.
Thank you, sir. Thank you all.
Thank you all. Thank you, Dr. Vijayan sir, for your excellent lecture. Mind-boggling. Very interesting, sir. Thank you so much. Very kind of you.
Students can write to me anytime if they have any query. So I'm open to students. Thank you all. Bye.
We will also encourage them to ask you, sir.
Yeah, sure, sir.
Thank you so much, sir.
Okay, sir. Yeah, I'm leaving, sir.
Okay, sir.